Hey all, this is Derek, and this is section 8.3, Operations with Functions. And this section is not bad at all. In this, we're going to be given a couple of functions and then basically asked to either add, subtract, multiply, divide, evaluate, that sort of thing. But it's all math we've seen before. It's just we're being given the directions in a little bit different format than we're used to. So for this first problem, we're given f of x is 3x minus 5 and g of x is 5x squared minus 2x plus 6, and we're asked to find f plus g of x. So this of x, this is not the same way this didn't mean multiply, this means evaluate at that. A lot of times people will think they should add these two and then multiply by x. Not what that's saying. This is saying the same thing as f of x plus g of x. So it's just saying to add these two functions together. So literally 3x minus 5 plus 5x squared minus 2x plus 6. And then we just combine our like terms. So easy math in this section. Minus 5 and 6 would be a plus 1. And that's it. So mostly it's just kind of not getting messed up by the notation. Same thing here, f minus g of x, same thing as f of x minus g of x. This is nice if we have more than one thing going. It lets us just do the of x once. So it could be kind of a handy shorthand, but they do mean the exact same thing. So for this one, we do have to be a little bit careful here with some parentheses. So I'm going to go 3x minus 5. Anytime we're subtracting, that's where we have to open a parenthesis, and then 5x squared minus 2x plus 6 in there. And then let me write that distributed. And then that'll be a plus 2x and a minus on the 6. And they're just back to collecting terms. So minus 5x squared, have 3x and 2x, that'll be 5x. Minus 5 minus 6, so minus 11. Okay, up next is f times g. And again, this is the same thing as f of x times g of x. Or I could also just write it f times g, and so we'll see all those notations. So this is just saying FOIL. So x minus 2 and 3x plus 1. So we'll do our first, 3x squared, outer looks like a plus x, inner minus 6x, and a minus 2. And then we just got to be careful to collect those like terms in the middle. So it finishes up as 3x squared minus 5x minus 2. And then division, in this case there's not much division happening, so it's just going to be x minus 2 is f of x over 3x plus 1. That's it. Okay, for this next round, instead of being of x, it's at a value. So we saw in the last section we can evaluate a function at some given value, and that's the exact same thing as what we have here. So another way of writing this would be to say f of negative 2 times g of negative 2. So I have two ways I can do this. I can either FOIL these out and combine it all and then shove it in the negative 2, which seems like more work, or I could just write out the FOIL while evaluating it at negative 2. And that seems like it'd be more straightforward because we'll just have numbers left. So let me do that version. We'll do negative 7, and then that's going to be times a negative 2 minus 5. And then we're multiplying that times g evaluated at negative 2. So that'd be negative 2 plus 3. And so I have my first thing times my second thing there. So this is going to be 14 minus 5 times negative 2 plus 3 would be 1, and then 14 minus 5 would be 9 times 1, or 9. This one is f minus g, evaluated at 3. And so, again, just to kind of show I can do it in either order, let me do this first as negative 7x minus 5 minus x plus 3. So I'm doing just doing the algebra first, and then I'll evaluate second. So that would be negative 7x minus 5 minus x minus 3, or negative 8x minus 8. So if I plug the 3 in there, now I got negative 8 times 3 minus 8, or negative 24 minus 8 would be negative 32. So then if I plug this 3 in just straight away as is and subtract, I would have negative 7 times 3. So this is the exact same problem, just done the other way. Minus 5. And then we're subtracting g of x. So that would be 3 plus 3. So this will be negative 21 minus 5 minus 6, or negative 26 minus 6, and so exact same negative 32. So I could do algebra first if that's convenient, and then evaluate, or I can just evaluate, whichever one seems easier. Okay, and then these last couple are just kind of showing that we can do some different things with function notation. And so this one right here, f of x plus 1, the same way if this said f of 7, I would plug in a 7 anywhere there's an x in f of x. Here I'm going to plug in x plus 1. So x plus 1, that's like my new x. So it's going to go right there and get squared, and then it's going to go right there as well. So this would look like 3 times x plus 1 squared plus 2 times x plus 1. And then this is easy to mess up and get x squared plus 1. That's not quite true, because remember that is x plus 1 from our factoring chapter, plus 2x, I'll distribute as I do this piece, times 2, or plus 2. And then I'm going to FOIL these out. You're also welcome to do the formula version. I'm just showing this because people often get lost when I do the other version. So if I do the FOIL, I would get an x squared, a plus x, another plus x, that'll be plus 2x, and plus 1. Same as x times x squared, 2 times x times 1, 2x, 1 times 1, 1. And then that's plus 2x plus 2, and then distribute the 3. So 3x squared plus 6x plus 3 plus 2x plus 2. And so there's a bit of math. None of it's super hard. It's all stuff we've seen, but there is a bit of it in this problem. And then 3x squared, we got 6x and 2x, so that'll be 8x. And then plus 3 and plus 2 for plus 5 on the end. This next one seems like kind of an odd thing to do, to evaluate at negative x, and yet there are times that is actually useful. It's a test for symmetry in pre-calculus. And so let me just show you what it looks like. So if I'm doing f of negative x, it just means everywhere there's an x, I'm going to put in a negative x. So negative x quantity squared plus 2 and negative x. So negative x times negative x would make positive x squared, and then the 3 is still in front, so 3x squared, but there's 2 signs there, so the double negative makes positive. Here there's just 1 sign, so then that flips that to negative 2x. That's it on that one. And then this one says f of x plus f of 1. Okay, so f of x is what I have right here. It's this 3x squared plus 2x, and I'm supposed to add to that plus f of 1, so that'd be 3, 1 squared plus 2 times 1. So 3x squared plus 2x, and that would be 3 plus 2 is 5.